All right, guys, Mr. Antonucci here with number 6 from the 2024 AP Calculus AB exam free response questions. So here we go. Number 6, the functions f and g are defined by f of x equals x squared plus 2 and g of x equals x squared minus 2x as shown in the graph. Let R be the region bounded by the graphs of f and g from 0 to 2 as shown in the graph. Write, but do not evaluate, an integral expression that gives the area of region R. So this is just the area of a region between two curves. The vertical distance is f of x minus g of x, top minus bottom. And to get the area of that region, you just integrate over the interval, which goes from 0 to 2, dx. And that's literally all we had to do for that one. You don't have to write the x squared plus 2 and the x squared minus 2x in the integrand. You could just use the function notation f of x and g of x because they've been previously defined in the problem. So number 6, part B, let S be the region bounded by the graph of g in the x-axis from 2 to 5 as shown in the graph. S is the base of a solid. For the solid at each x, the cross-section perpendicular to the x-axis is a square. So we're in region S, we're making squares, and we're slicing them vertically. So if I pull that slice out and put it over here, it's going to kind of look like that. And it's a rectangle with height equal to half its base in region S. So what I'm doing is that this distance is the base of the rectangle, corresponds to right here. That's the base. And then this would be the height. And the height, they said, is equal to 1/2 the base. Now notice the base is also the distance from the graph of g to the x-axis, no matter where you put your slice. So this is equal to g of x, and this is equal to 1/2 g of x. So the area function is 1/2 g of x squared dx. To get the volume, we would integrate that over the interval 2 to 5. Okay, so in terms of actual work, we have to figure this out. So the integral from 2 to 5 of g of x, x squared, minus 2x quantity squared dx. All right, so we have to FOIL that out. And when you FOIL that out, you're going to get x to the 4th minus 4x to the 3rd plus 4x squared dx. Now we have to anti-differentiate that. So it would be 1/2 times 1/5 x to the 5th minus x to the 4th plus 4/3 x to the 3rd, evaluated from 2 to 5. Now, at this point, we need to plug in the 5 and the 2. And then it's going to be a string of like 6 terms multiplied by 1/2 that you have to subtract and combine, and there's going to be fractions involved and exponents of 5. I'm thinking if you just leave it with the 5 and 2 plugged in, it should be okay. We did something similar to this in I believe it was question number, which one was it? I think it was question number 5, part A, where we left it as 4 minus, what was it, 4 over 19. Okay, so I'm pretty sure you're going to be able to leave it like that. So let's just do that. All right, so you'd have 1/2 times the function evaluated at 5, so 1/5 x to the 5th minus 5 to the 4th plus 4/3 5 to the 3rd, okay, minus 1/2 the function evaluated at 2. So 1/5 2 to the 5th minus 2 to the 4th plus 4/3 2 to the 3rd. All right. if you're wondering, this should come out to 414 over 5. But again, I'm not sure that they're going to make you do that. Okay, so on to number 6C rather. Write but do not evaluate an integral expression that gives the volume of the solid generated when S, as described in part B, is rotated about the line y equals 20. So we're doing a line here. Okay. If you imagine a handle on here and we're going to spin it, we're spinning region S, so I'm going to take this slice and spin it around the curve. We're going to get a washer. Okay, so I'm going to redraw the region down here, sort of. Okay, so we have the graph of G and the line y equals 20, and the vertical line, what was it, x equals 5. So this is S. Now the slice goes right here, so this is our inner radius, and then our outer radius is going to go all the way down. So big R is going to be 20. Because the outside boundary is the x-axis, that's getting rotated around the line y equals 20, and it's always the same. Little r is the distance from the axis of rotation to the curve g of x. So this distance for little r is going to be subtracted by however high up g of x is. So the volume is going to be pi times the integral from 2 to 5 of big R squared minus little r squared, 20 minus g of x squared dx. And you can leave it like that, and you're done. All right, guys, hope that was helpful to you. Again, at the time of this recording, the College Board has not released the scoring guidelines, so I do not know the points breakdown for each of these sections, but I've worked through these in advance and also confirmed it with another resource, so I'm fairly confident these questions and solutions, rather, are correct. All right, hope that was helpful to you guys. Take care.